In number 10, they want us to find the second derivative of y with respect to x. So let's get started. X squared plus y squared is equal to 25. So a nice circle equation. Let's go ahead and differentiate. So we get 2x dx dx plus 2y dy dx equals 0. So this is 2x plus 2y dy dx equals 0. And that means that 2y dy dx is equal to negative 2x. And if we divide both sides by 2y, these cancel, and we get dy dx equals, the 2's cancel, negative x over y. Now to find the second derivative, all we really need to do is differentiate dy dx with respect to x. And since this is a rational expression, that means that I am going to have a quotient rule problem. So let's take the derivative of the left side, and we have the second derivative of y with respect to x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Alright, so this gives us d dx of negative x, so that's going to be negative dx dx, which is just negative 1 times y is negative y. Minus a negative x is going to be plus x, and the derivative of y is dy dx over y squared, and that is equal to the second derivative of y with respect to x. Now at this point you may be tempted to draw a box around this and call it a day, but the problem is I have a dy dx in here and I can't solve for a derivative in terms of another derivative. But the good news is I know what dy dx is. That's equal to negative y plus x times negative x over y. Now we don't like compound fractions, and the only problem here is the denominator of y. So let me multiply top and bottom by y. And if I do that, we get d squared y, second derivative of y with respect to x squared, equals negative y squared minus x squared over y cubed. Let's factor out the negative, and we have negative x squared plus y squared over y cubed. And that's my second derivative.